Everyone, and welcome back to my channel IBmathlogy. If you are watching this video, you are probably staring at complex numbers in your AHL syllabus and thinking, what even is this? Don't worry, by the end of this video, complex numbers are going to feel real. So let's start. So before understanding what is a complex number, let me first write an equation x square minus 1 is equals to 0. So this equation has two roots. I will find it like this. So x value is plus or minus 1. But what if I give you an equation like this, x square plus 1 is equals to 0. So I will solve it like this. But now I cannot write this because I know that inside under root we should have positive numbers. So here complex numbers come into the picture and they have defined under root minus 1 as I. Now what is this I? This I is iota, or you can say that it is a imaginary unit. I stands for this. So from there I can say that if I am writing z is equals to a plus bi, it means z is my complex number, and from here I can say that a is nothing but real part of the complex number and b is imaginary part of the complex number. It means every complex number will be having some real part and some imaginary part. For example, I can write z as 3 plus 4i. So my 3 will become the real number and 4 is my imaginary. Now there are some operations in complex number like the real numbers. So those operations are, let's say I have first complex number as 3 plus 4i and the second complex number is 1 plus 2i. And now what I want to do is I want to add these two numbers. So I will write both the complex numbers and I can only add real to real and imaginary to imaginary part. So the answer is 4 plus 6i. Now what if I want to subtract these two numbers? So I will again write the two numbers, two complex number, and here also I can subtract real to real and imaginary to imaginary. Similarly, the third operation is multiplication of these two complex numbers. So I will multiply using FOIL method, so which will be 3 plus 6i plus 4i. Now here it will be 8i square. And since I have mentioned that I is nothing but under root minus 1, so I square will be minus 1. So I can replace this value over here. So I will get minus 5 plus 10i as z1 into z2. So the key trick is always replace I square with minus 1 in any question. Now let's understand another concept, that is complex conjugate and the division. Now first of all, what exactly is this? So for any complex number z is equals to a plus bi, my complex conjugate will be represented by z star and it is nothing but a minus bi. So we just have to change the sign of the imaginary part. So this is the complex conjugate. You just flip the sign of the imaginary part, you will get the complex conjugate. Now why does it matter? It matters when we are doing division, because we cannot have an imaginary number in the denominator. For example, if question is simplify 3 plus 4i with 1 plus 2i. Now you cannot solve this further. So we will rationalize with the complex conjugate of the denominator and we get like this. Now why we are multiplying and dividing by the conjugate? Let's see. My numerator will be the same, but in denominator if you see, this is a plus b and this is a minus b. It means I can apply my identity as a square minus b square. Now if I further open the bracket, that will be 4i minus 4 to the 8i square. Here again I am getting I square, so I will be replacing I square with minus 1. Now in the denominator I'll get 1 minus 4i square. Here also I can replace I square with minus 1. So this will become plus 8 upon 1 plus 4, that is 11 minus 2i upon 5, which I will be writing like this, so that I can clearly define that this is my real part and this is the imaginary part of the complex number. And there is a one quick tip, that z into z asterisk, that is the complex conjugate, will always give you a real number. Why? You can see in the denominator, when I multiplied these two, I got 1 minus 4i square, that leads to 5. Now the next topic that comes is Argand diagram. This is also a very important topic when it comes to complex numbers. So Argand diagram is nothing but the simply plotting on x and y axis. Normally we plot 2, 3 real numbers. Here also we can plot complex numbers. Now the x-axis will act as a real axis, whereas the y-axis will act as the imaginary axis. So we can actually plot complex numbers on a diagram that is known as Argand diagram. So if I take a number as 1 plus 2i, so I can actually draw it by putting 1 on real and 2 on imaginary. So I can say that this z, which is 1 plus 2i, so I will write z is equals to 1 plus 2i. So this is how we can draw. Now if I join this like this, O, B, and this point as A, so in my diagram if you see, I have made this point as A, this as B, and this as O. So the length of OA will be my magnitude of the complex number, and the magnitude we will find by squaring the real and imaginary part. So this will give me root 5. So I can write that my magnitude is nothing but root 5. Now the angle can also be found out. Angle is that line that makes with the positive real axis. Positive real axis. So this angle theta, I can say that. And this theta is known as argument, written as ARGZ, which is nothing but my angle. Now how will I find? So my argument of Z will be tan inverse B by A. So these are some things which you need to remember. Now if I summarize, so for any complex number a plus bi, I have two things. First one is the modulus, that is the magnitude, which is a square plus b square, and second one is the argument, that is nothing but tan inverse b by a. The exam tip is always check which quadrant your complex number is in before calculating the argument. Now till now what we have studied is all that comes in Cartesian form. Why Cartesian form? Because I am writing my complex number in Cartesian coordinates a and b. Now there are other forms also, like polar form. Now what is polar form? The same z I can write as r cos theta plus I sin theta. Now note that we have r as modulus z, and this argument theta, this is argument theta, So I can write it as arc Z. So if we have these two things, we can write in the polar form. We have another form as Euler's form. Euler's form means I can write my complex number as r e to the power I theta, and my r is again modulus and theta is my argument. Now let's convert some Cartesian form into polar and Euler form. Now let's take an example of z is equals to 1 plus root 3i. Now I want to convert this into either polar or Euler form. So for that I need r, which is modulus z, which I can write as 1 square plus root 3 square. That will be 2. The second one is the argument theta, that is tan inverse b by a, and tan is root 3 at pi by 3. Now since this come in quadrant 1, so there is no adjustment that is being needed. So once we get our mod z and theta, so we can write z as r cos theta plus I sin theta. And if you put cos pi by 3 and sin pi by 3 value, you will get to the Cartesian form again. And if I want to write it in Euler form, that will be 2 e to the power I pi by 3. So this is how we can convert any complex number. Now let's understand a tricky example. Another example I can take as minus root 2 plus root 2i. So we will first find out the modulus, that is minus root 2 square plus root 2 square, that will be 2. Now the argument will be tan inverse b by a, which is tan inverse minus 1. Now since it is minus 1, now if you see the coordinate is root 2 minus root 2 comma root 2. It means if I plot it, it will be in the second quadrant. And if I want to draw it, it will be like this. It means tan is 1 at pi by 4. So I have calculated this angle as pi by 4. But my argument is always with respect to positive angle, positive x-axis. So my angle will be pi minus pi by 4, which is nothing but 3 pi by 4. So this becomes my theta. So you have to be very careful where these points lie. So I can write my complex number now as 2 cos 3 pi by 4 plus I sin 3 pi by 4. And if you want to write it in Euler form, that will be 2 e to the power I 3 pi by 4. Now it is not always necessary that you will be having z as a plus bi. We can sometimes get like this also. It means I can write this as 0 minus 3i. So this is how you can find your a and b. Now again we can calculate our r, which is 0 square plus 3 square, that will be 3. Now my argument will be tan inverse b by a, which is infinite. Infinite is at pi by 2. So I can write my z as 3 cos minus pi by 2 plus I sin minus pi by 2. Or in Euler form, I can write e to the power minus I pi by 2. Now if this comes in a paper 1, you have to do all the calculation. But what if it comes in paper 2? So you can use your GDC, and in that I will be uploading in my YouTube short how to quickly get modulus and argument using your GDC. Now the next very important topic is de Moivre's theorem. This theorem is helpful when you have some raising complex numbers to power. So if I write cos theta plus I sin theta. Now what if I want to calculate some z to the power n? It means I can put sin theta whole to the power n. But to calculate theta to the power n will be difficult. So according to this theorem, it becomes r to the power n, and this n gets multiplied with theta, both the thetas. So this is how you can use de Moivre's theorem to solve any complex number. Now this was all about polar form. What if I want to write z to the power n in Euler form? Again, it will be r to the power n and e to the power I into n theta. So we will never be doing theta to the power n. So we can multiply the argument by n, raise the modulus to the power of n. And sometimes you can see in your books also, it can be written as r cis theta. Cis theta stands for cos I sin. So if I want to write this one, so this will r to the power n cis n theta. So the expansion of this will be this one. Now let's take an example. If we have a complex number, let's say in polar form, 2 cos pi by 6 plus I sin pi by 6. Now I want to calculate what is z to the power 5. So that will become 2 to the power 5 cos 5 pi by 6 plus I sin 5 pi by 6. So this is how we can calculate, and these two values you can calculate using your GDC. So when you will use your GDC, 2 to the power 5 will be 32 and cos 5 pi by 6 is 0.866 and sine will be 0.5. So if I further solve, I will get my answer as minus 27.7 plus 16i. So this is the value of z to the power 5. Now imagine what if you have to multiply this 5 times to get z to the power 5. So this will be very difficult. So in these cases we will use de Moivre's theorem. Now the next very important topic is finding nth root of any complex number z. So de Moivre's also helps find roots of the complex number. So if I am writing z as r e to the power, let's say, theta. So the nth root, so I can write this as 1 upon n e to the power I theta plus 2 pi k whole divided by 2 pi k by n, like this. So it means what I am doing is, I know that my sine and cos have a period, they repeat themselves after an interval. So that's why I have written theta plus 2 pi k. And here my k will be starting from 0, 1, 2 goes till n minus 1. For example, we can find out cube root of unity. Now how we will find out? It means z cube is equals to 1. So here r is 1, theta you can calculate as 0 and power is given to me as 3. So I can write zk as, I will be using this above formula. So I can write this as 1 to the power 1 by 3 e to the power I 0 plus 2 pi k by 3. Now if I put k as 0, so my first root will be e to the power 0, that is 1. My second root will be e to the power I 2 pi by 3 if you replace this k as 1. So 2 pi by 3 is basically 120 degrees. So I can write this as cos 120 plus I sin 120, and you can use your GDC to solve it further. And the third root will be e to the power I 4 pi by 3, again replacing k here as 2, which is nothing but cos 240 plus I sin 240. Now we can draw Argand diagram showing 3 equal space points using a unit circle from this also. So if you see all 3 roots z0, z1 and z2, they sit equally spaced from the unit circle. This will always happen with the nth root. They will be equally spaced by 2 pi by n. So this is very important to note. Now there is an exam tip. In AAHL exam, they love asking you to plot nth root on Argand diagram. So what you have to remember is, they always form a regular polygon on a circle with radius r to the power 1 by n. So this is what you have to remember. Now at the end, I can give you some exam tips which you have to remember. First one is, always replace I square with minus 1. This is the most common mistake that students do. Second one is, always check your quadrant whenever you are finding argument of z. Third one is, use GDC if it is a paper 2 so that you can verify your modulus and argument. And the fourth one is the most important, which is your best friend for powers and roots, that is de Moivre's theorem. And the next one is, nth roots are equally spaced. Where they are equally spaced? On a circle. So whenever you are drawing any Argand diagram, you should be careful. So just remember these 5 tips whenever you are solving any complex number question in exam. And that's the complete complex number topic for IB Math AAHL. If this video helped you, please give it a thumbs up. It really helps the channel grow and reach more IB students like you. Subscribe to IBmathlogy. And in my next video, I will be solving some complex number questions which already came in the IB exams. So see you there in the next one. Have a great day, everyone.